Okay, so now I'm going to go to the second planet. The second planet is Eurus 2, and it is a highly unstable planet, and the only difference between this and Beta Prime is going to have the same amount of gravity, but it is going to have a changing atmosphere. It will shift from Earth-like atmosphere to extremely more dense, as far as atmospheric density is concerned, and also extremely less, more towards Beta Prime. This will get interesting for us because what it's going to allow the students to do is to really play with the curve of the flight path, which is mainly due to the fact that the golf ball is spinning. So it's a ball that's in spin, and it also has dimples, which reduce drag. All right, so our first challenge question says the hint is observe the new forces acting on the golf ball during its flight on a planet with an atmosphere. So in Beta Prime, we had no atmosphere and we only had one force, and that was the weight force, which is from gravity. Now we're going to notice, and after we hit the ball, we'll see how all of the other forces sort of relate to each other and how they are affecting the flight path of the ball. Another thing that we have included right now is wind. You're also going to see this graph as well. This graph is just showing you where in the projection, so you can get a little bit of prediction in of if the gravity is going to go thicker or less. And this actually plays a little bit cool in the strategy because there are a couple pathways you can take on these levels on this planet. And different strategies can play out by knowing if it's going to be thicker or thinner, the atmosphere. So I'm going to go ahead and set up my shot. We have a new interface item right now that's coming in on the right side where it's going to allow us to dictate the face angle and the spin of the ball. There's two components that are getting added in which will affect the spin of the ball. So here's the face angle. This is how I'm holding the club. And you can see how it's curving. Now I have the swing path that I'm taking in addition. Okay, so one of the interesting things about this is that you can notice that there are different paths that you can take and different face angles that you can have. And there are actually 9 total different types of shots in golf, and because of these two components, there are 3 major settings that you can set right in the middle, far left, far right. Same for the face angle, right in the middle, far left or far right. And that equates to the 9 different types of golf shots that you can take. So for a golf enthusiast, this could offer a unique sort of expertise that they might have by knowing where they are in the shot and where the wind is. But for us, we can notice that the golf course is curved, it's going to arch around, and I'm going to have to fight this wind. So I'm going to want to be starting to curve the ball and learning what is the best type of shot depending on where I am, where the wind is. There's also these power-ups right here, which I'm going to try and hit. So let's see if I can curve this in a way that'll allow me to get to that. Okay. So let's see if this will do it. Now let's check my wind. Let's go to the right.
Can you take us through these things again?
Sure.
What makes those change?
So, well, the information that's provided in the telemetry will scale up as the game progresses because we don't want to clutter any of the students with too much information too fast. And so we started off with just mass and weight, and now we're at launch angle, speed, and kinetic energy. All this breakdown is showing you is the different types of data that right now are occurring real time. So if I want to click on kinetic energy, it's going to tell me what kinetic energy is. It's going to provide me with a Wikipedia link. It's also going to tell me the exact amount of kinetic energy that ball is going to leave with. Now you see that I put in, right here, 133 joules is going into that. 129 is going to be registered as kinetic energy. That other 4 right here is the gravitational potential energy that's adding to the kinetic energy. This is a great opportunity for facilitation because a lot of these types of energies, the forms of energies, will need some clarification just to understand the difference between the different ones. The kinetic energy at the baseline is the movement energy, mainly when the ball is traveling. So, and you can see that I started with much more than 129, but this right here is all lost to heat and sound upon the impact of the ball, and then the remaining potential energy has transferred in to kinetic, changes to kinetic in the ball, which is blue. So let me go ahead and hit this ball and see how it goes. I gotta fight that just a little bit. There we go. All right, got a good nice curve. Okay, I'm gonna pause it right quick. So in this physics visual, we're seeing the different component forces that are affecting the ball. We have lift, drag, and gravitational force, which was there. The dimples on the golf ball, which is a good talking point to say, is that it reduces the drag, and in doing so, it also makes it go farther. Now the lift, whether you want to introduce the Bernoulli effect or not, I would suggest not. Although, in essence, what it's talking about is that because of the spin, and you're only going to ever have backspin on a golf ball, and the axis can tilt, but you only essentially ever have backspin, it is causing a difference of speed of particles that are traveling around the golf ball, where they are traveling faster over the top and slower over the bottom. And because of this, and whatever effect this has on the actual ball, you get this lift force that is driving up. Another thing to address is also the units on drag and lift and weight, and we use the unit a Newton, which is the standard unit for these forces. So essentially, these act all as the same types of telemetry. You're going to get the exact same type of visual. So when I click on any of these, let's pick weight, we get a explanation like many of the other telemetry facts, and then we can also find the Wikipedia page. The good thing about this is that at every point in time in the game, when you have a labeled telemetry, and you can pause it during the physics visuals, you can always take a little bit of a deeper dive and clarification to what these variables and what these symbols are representing at any point in time in the game. This also offers a really good platform for facilitation with the teachers if they call upon the students to do a little research on a certain component or aspect of a particular planet or hole. Ooh, that's actually one of the best shots I've had for this level. It was right in the money. So where's my wind? My wind is straightforward. I'm just going to go dead shot. I'm actually not going to put any spin on this ball, just to see if I can get it over to there. Oh, it's like right on the rough. All right. That looks good. Now, but where's the wind? Oh, the atmosphere's thick. So actually, in the interface, there's one thing that you can click on the left if you want to double check the graph at any point in time to see where you are in the particular round and what the gravity is. Make that go away. All right. Oh, that had a little bit of right. Oh, take it, wind. Yeah, it's on the green. Okay, time for a putt. See if I can get a birdie. Slowly moving, do it like that. 0.6. Oh, what? Oh, I see. It sloped back. I didn't even register that. How that sloped back right there. So I should have put it a little bit farther out. I didn't even realize that. Get in there. Gotta drag back. There we go. All right. 320. Okay. Okay, so my fourth challenge question on Planet 2, Hole 1, of the following which does not determine the flight path of the ball. So this is actually a tricky question because one of the words that we are using here is determine. So this is having a direct effect on the flight path of the ball. We know that drag was one of the force vectors. That is definitely dictating a flight path that it can take. It will make it go less far. Lift is also giving it more raise. It will go a greater distance. This is definitely affecting the flight path of the ball. Gravity, as we saw before on the first planet, was one of the only things that was affecting the flight path of the ball. And velocity is sort of the only outlier. Velocity is interesting, and this is what I would recommend as a facilitation point, is velocity is actually not dictating anything. Velocity is a way that we describe a direction and motion of something. It actually has no dictation over what's going on. So the only real inputs that we have are the forces, the three forces that we see on the right. So we know that which does not determine the flight path would have to be, by that reasoning, velocity. So Let's see if we're right. We are correct.